Okay, I'll start with you this short video, and we want to finalize the DC circuits. We have learned now Ohm's law, stored energy in a coil, stored energy in a capacitor, how we connect resistors in series and in parallel, and how we obtain the total resistance, how we use the current divider rule, the voltage divider rule, and also we know the theorems, source conversion, Thevenin's, Norton's, and superposition, as well as the methods of analysis, mesh analysis and nodal analysis. And what is left is just a topic I want to describe for you before we finalize uh, the DC circuits. Let's demonstrate the power. Power. What is the power? Okay. Power P equal power is defined as the voltage times the current. Okay. So if we take a resistor R, and here plus minus V, and there's a current passing through that resistor. So what is the power? Power is simply equal V times I, and from Ohm's law, V equal R times I, then times I, okay? So this will give you R I squared. So this is power dissipated in a resistor, okay? So it's heat converted to heat, okay? And the units is watt or the value. So the resistor consumes power, okay? i.e. resistor consumes power, okay? Convert power or energy to heat, like a friction. Exactly, it acts like a friction, okay? So power is dissipated as heat, okay? So this is the power in a resistor. And let's take a voltage source plus minus E connected between A and B, and there's a current I here, okay? So power supplied by the source is P equal E times I. Okay, in watts. So if P is positive, it means power is supplied. If P is negative, this means power is absorbed by the source. Same for a current source. So if we have a current source, alaykum salam, and we have I and V plus minus V, then P is again V times I. If P is positive, then the current source Alaykum assalam. Then the current source supplies power. If P is negative, then the current source absorbs power. Okay? Let's take a few examples and see how we know this phenomenon. Example. We have a voltage source here, plus minus 100 volt, and we have a current, a resistor, let's say 10 ohms, and we have another source, plus minus, let's say this is 20 volts, 100, okay, and this is the circuit. Now we can calculate I. I is equal 100 minus 20 divided by 10. So it will be 80 divided by 10, it will be 8 amps. Now, if we take this source, let's say this is E1 and this is E2, then E1 equal 100 volts, which means that P1 is equal E1 times I, which is 100 times 8, so it's 800 watts. So you have here plus minus E1 supplies a current of 8 amps. This will give power P1. So P1 is positive, i.e. source E1 supplies 800 watt to the circuit. Okay, it's very easy to calculate that. Let's look at the other source, the 20 volts. Now we have plus minus E2, which is 20 volts, and we have a current here, I equal 8 amps. Okay, so you see the direction of the current means the power is going that way. So if we want to calculate P2, we say P2 is equal E2 times I2. Where is I2? Is this I2? So this P2 equals supplied, okay, which is equal 20 times minus 8. I2 in the other direction is minus 8, so it is 160 minus watt. So the power, i.e. source E2 supplies minus 160 watt to the circuit, which means that i.e. E2 takes or absorbs 160 watt. Okay, so in this case E2 absorbs power while E1 supplies power. Then for the resistor, what we have, R is equal to 10 ohms and the current passing through it equal 8 amps. So the power of the resistor is 8 times 10 squared, 8 squared, that's I squared times R. So will be 8 times 8 is 64 times 10, 640 watt. Okay, so this power is dissipated in the resistor. So let's look at the circuit again. We have E1, okay, and we have a resistor here, R, and we have another voltage source, plus minus E2. Now E1 here supplies P1. The resistor takes PR, and the second voltage source takes P2. So what we have, source 1 or E1 gives P1. That P1 goes to PR and P2. Okay, so P1 we have calculated is, let's go back to it and see what is the value we have calculated. P1 is 800 watt. So P1 is 800 watt. This is distributed to PR, which is equal, we have calculated PR 640 watt, 640 watt, okay. And E2 we have calculated I think 160 watt. So if you add this plus this, comes to 800 watt, which means that source E1 supplies a total power of 800 watts. Part of it will be dissipated in the resistor, which is 160 watts, okay, 640 watts, and P2, okay, this is P2. So part of the 800 will be dissipated in the resistor 604, and the other part will be supplied to source E2. So in this case, source E2 takes power. It doesn't supply power, it takes power from the source. Take another example. Let's have a a current source here, okay, and let's have a voltage source here, plus minus 100 volt. Let's assume that we have two resistors here, okay, and we want to determine, let's say this is 20 ohms and this is 80 ohms, okay, and let's say we have 2 amps here. Now we can solve this using any method, okay. We can use superposition, for example. Using superposition, we have two sources, means we'll be having two individual circuits. Let's draw both circuits. We have 20 ohms and we have 80 ohms here, and the current source is an open circuit because we want to make it zero. So open circuit here, plus minus 100 volts. And let's calculate the current I in here, okay? So I is equal 100 divided by 20 plus 80, so that will be 1 amps, okay? Let's look at the other circuit. Now we have 80 ohms here, we have 20 ohms here, and we make the voltage source as short circuit, and we have the current source, okay? And we know this current is 2 amps. So we can calculate this current and this current. Let's say this is I1, double prime, and the one we calculated here, let's call it I1 prime, okay? This is I1 prime. And let's calculate I1 double prime. Using current divider rule, it will be 80 divided by 20 plus 80 times 2. So it will be 160 divided by 100. It will give you 1.6 amps. 1.6 amps. Okay? And we can calculate also I2. Okay? In here, let's assume this is I2 prime. So I2 prime is equal also 1 amp. It's the same. While I2 prime here, let me just take this part. Okay. Using again the same current divider rule, I2 prime will be, instead of 80, will be 20 divided by 20 plus 80 times 2. So this will be 40 divided by 100. So it will be 0.4 amps. Okay. So that's what we have. Now if we go back to the original circuit, what we have here, we have 2 amps and we have 80 ohms here, okay, and we have a resistor here of 20 ohms, and we have a voltage source here plus minus 100 volts. Now we calculated I1. I1 is equal I1 prime minus I1 double prime. Why minus? Because in the second circuit, you see the direction is the opposite to the first circuit. So in the first circuit should be plus, the second circuit should be negative, minus. So this will be 1 minus I1 prime, which is 1.6, minus 1.6. So it will give you minus 0.6 amps, okay? And I2 is equal I1 double prime, or I1 prime in the positive direction, plus I2 prime plus I2 double prime, because they are both, as you see, in the same direction. I2 prime and I2 double prime are in the same direction. One is 0.4 and one is 1, so it will be 1 plus 0.4, so it will be 1.4 amps. Now, coming back to the circuit here, we have I1 is negative, minus 0.6 amps, while I2 is positive, which is 1.4. I2 is 1.4 amps. So the 2 amps supplied by the current source, 1.4 will come to this side, and the other 0.6 in here is 0.6 amps will go to the other side, okay? Now, to calculate the power supplied by the voltage source, we need this voltage plus minus, say, Vx. So what is Vx? Vx is equal 80 times I2. So it will be 80 times 1.4, okay? So it is 8 times 14, 8 times 14, so it will be 8 times 4 is 32, 8 times 1 is 8, and 3 is 11, so will be 112 volts. Now we can we can calculate what is the power P1 supplied by the voltage source. So it should equal to 100 volts, that's E, times the current, okay, supplied by the voltage source times minus 0.6. So it will be minus 60 watts, which means it turns out to be negative, which means that actually source, the 100 voltage source takes power, it doesn't supply power, okay, because it's negative. So you say IE source 100 volts absorbs power. Okay. Now let's look at the current source. Current source. Let's say this is equal to P2, so it should be Vx times the current supplied by the current source, which is 2 amps. Okay, so Vx we have calculated 112 volts, 112 times 2, so it will be what? 2 times 2 is 4 and 22, so 224 watts, and it's positive, means the current source supplies power. Okay, now let's calculate the power dissipated in the resistor of 20 ohms. So it should be 20 times the current passing through that, which is 0.6 squared. So it's 20 times 0.36. So it is 2 times 3.6. So it should be, I think, 7.2 watts. Okay? And let's calculate the power dissipated in R equal 80 ohms. So this should equal to 80 times the current squared, which is, let's go back to it, which is I2 1.4 times 1.4 squared. So this is 80 times 1.4, 14 times 14, let me do it with you again, 14 times 14, that's, okay, 4 times 4 is 64, 4 times 1 is 104, okay? 4 times 4 is, 4 times 4 is 16. If you have a calculator, go and, I don't have a calculator, so 4 times 4 is 16, not 64, I'm mistaken. So it's 16, okay? 4 times 1 is 4, and we have 1, then that is 5. So 56. And we have 14 here, then 6, 9, 1 pint. 2 pints. So this 80 times 1.96. So it is 80 times 1.96. You have a calculator, you calculate it. Let me do it through my telephone, my telephone calculator. I'm sure you have done that now. Okay. So 1.4 squared, 1.4 times 1.4, 1.96, that's correct, times 80, then it is 156.8. So 156.8 watt, okay? Now let's go to the circuits. Now what we have, source 1 plus minus takes P1 is negative, and P1 is 60 watts minus 60 watts. And the resistor here takes PR1 equal 20 ohms, 7.2. Okay? And we have a current source here supplies P2 equal 156.8 watts. Okay? And then we have the second resistors, R2, we have from this here, PR2 is equal 156.8 watts. Then P2 is not 1, P2 is 224. So let's be correct that. P2 is 224, okay? 224 watts. If you look at it carefully, now current source supplies P2, which is equal to 224 watts. Where this 224 watts goes, so this is P2 equal to 224 watts. Now, it will split into three parts. Part will go to source 1, P1, 60 watts, to source E1, okay? The other parts will go to PR1, which is equal 7.2 watt, yes, 7.2 watt. And the other part, the third one, it will be 156.8 watt, which goes to resistor 80 ohms, 156P R2 equal 156.8 watt. Now, if you sum 60 plus 7.2 plus 156.8, if you sum them, they should give you the 224, or the power supplied by P2. Let's do it and see. Okay, I'll do it in my telephone. So we have 60 plus 7.2 plus 156.8, it is 224. If you don't get 224, it means you have done a mistake somewhere and you should try to correct it. 224 equal P2. Okay? So by now you should understand how we determine the power supplied by a voltage source or a current source. If it is positive, then that power is supplied to it. It means that source gives you power. And if it is negative, no. It takes power from you. Like if you lend money to somebody, if you give somebody money, it means he owes you. You gave him money, that's positive money. But if you give him positive money, if you give him negative money, it means you take money from him, okay? That's exactly the same way. So let's finalize the DC circuits. Now you know a resistor dissipates power. P equal R I squared. It transfers to heat, like a heater. If you have a heater, what is a heater? It's an element, a resistance. You give it a current, you give it electric energy, that electric energy transforms to heat, okay? If you have a coil, L, then it does not dissipate power, actually it stores energy. So we say stored energy, W equal half Li squared. So this energy stored as magnetic field. Like if you have a transformer stores energy as a magnetic field. It becomes a magnet, okay? And if you have a capacitor, see, then W is stored energy as electric field, okay? And it's equal half CV squared. So you know that a capacitor does not dissipate energy, but it stores energy. A coil does not dissipate energy, but stores energy. A resistor dissipates energy, exactly like a friction. If you have a coil, it acts like a mass. If you have a capacitor, it acts like a spring. So resistance acts like friction, while a coil acts like mass. You know, a mass stores kinetic energy. Mass kinetic energy. Friction losses. If you have a capacitor, it's acts like a spring. Spring. Spring, you know, stores potential energy. Okay? We'll talk about this more when we go to AC circuits. So the next video, we'll start the AC circuits. Okay? So talk to you later. Thank you.